today's problem is binary search. So the problem is we are given a sorted integer array and we are given a target value. Our job is to find this target value inside this array and return the index of it. Okay, so the question is simple. So now let's look into the logic. The logic must be in order of log n. So the binary search logic is, so first we have two pointers. We have start pointer, and start pointer will be pointing to 1, and the end pointer will be pointing to 12. So the binary we have two pointers. Now we have to find the middle value of the two pointers. It will be 5. Okay, now we check if 5 is our target. In this case it is not. So now we check if the target value is greater than 5 or it is less than 5. In our case the target value is 9 and it is greater than 5. So we move our start pointer to mid plus 1, which is 9, and our end pointer will stay the same. Now we calculate the mid pointer again. The mid pointer will be 9. So now we check if mid pointer is equal to target. In this case it will be equal. Now and we return the index. So this is binary search. The logic is so simple. So this will run in the 10 comes of order of log n. So now we have to call this binary search using recursion. So how we have to do? So we'll do that by having another function called helper function. So inside this function we'll be passing two arguments. One is the left pointer and another one is the right pointer. Okay. Now after having these two functions, we have to calculate the middle value. The logic to calculate the middle value is we have to add the two pointers and integer division it by 2. This will give us the middle value. So I want this L plus R to happen first, so I am putting this inside a bracket. So next what we have to do is we have to check if the value of the middle pointer is equal to our target. So if it is equal, we have to return our index, which is our middle value. Simple. So if it is not equal, we have to check if our middle value is greater than our target. If it is greater, what we have to do? So we are doing this using recursion. So first we have to return. We have to return and we have to call our helper function, which is h, and we have to pass arguments. So now we should pass the argument different. So now our middle value is greater than our target. So if the middle values, so let's say we are searching for 3. So the middle value here, the middle value is greater than our target. So if we are searching for 3, then our middle value is greater than our target. So what we have to do is we have to move this end pointer to mid plus 1. We have to move this end pointer to 3, and we have to search in this region of the array. So how to do it? We have to the start pointer will be the same, the left pointer will be the same, but the right pointer will be mid minus 1. So let's say if our target value is, now let's say if our mid value is less than our target. If it is less than our target, first we have to return and then you have to call our helper function like before, and in this case our target value should be around here, right? Our target value should be around here. So now what we do, we have to increment the start. We have to increment the start by mid plus 1. So the left pointer will be mid plus 1 and the right pointer will remain the same. So after doing all of this, we have to call our original helper function. Before calling it, we have to return, and we have to call it. We have to call it with some values, right? So first, initially, the L pointer will be 0 and the R pointer will be len of our array minus 1. Minus 1. So this is the solution. Let's try to run it. So we got some error. F3. So now we had a small error. So in the question they said if there is no target value in that array, we have to return minus 1. We didn't do that. So if there is no target value, then the L pointer will be greater than the R pointer. So in that case, we are returning minus 1. Now let's try to run it. So all the two test case passed. All the test case passed.